So welcome to DevHour. Today's roundtable discussion is going to surround serverless architecture and functions as a service and anything else we decide to dip into. My name is Heath. I'm going to be the sort of host moderator of this thing, but I want to keep the discussion open, so anytime you have a question for each other, just ask it. Roland Rainiers, developer at By the Pixel. We've got Scott Reinen, right?
Yep.
Okay, excellent. From Move On, do you say moveon.org?
Yes.
Okay. We've got Nick Stacaro.
Yes.
Very good. Nick, where are you from?
So I work for a company called Miner and Kosh, but my main serverless project is called Cryptic.
Right. Yeah, and you created Cryptic.
Correct.
Right.
Yeah.
And that is a serverless-based application, so we'll talk a bit about that.
Cryptocurrency?
Yes.
Okay.
Seems right.
Yeah.
Randon Kelly with Aptis here in Denver as well. We got, remind me of your name? Mark Missy.
Yeah.
He's with Vivo, and you guys run some serverless in production.
We do.
Which is very cool. You're going to hear about that. And
James
Gibson, right?
Yes.
Welcome. And you're more on the DevOps sort of side of things, right?
I'm all over the place.
All over the place.
There's no limitation
Perfect.
in the things that I touch.
All the hats.
All the hats and hats that I did not know existed. So.
Where are you at?
New
thing.
Yeah, new thing. Working recently just started and launched publicly a consulting company with my wife actually.
Oh, cool.
So
Nice.
yeah, that's kind of our new year present to ourselves.
Nice.
Awesome.
That's great. All right, so I guess I'll open it up on the floor. So when you're deciding, you're building an application, what makes you think, I want to build this as a serverless application?
So from someone who did that, like just from a side project that I had an idea in my head, the main driver for that was cost. I mean, I've run in previous jobs and other projects, I've racked up tons of server bills, like thousands of dollars just to test an idea out.
Right.
And I think my monthly cost for serverless is like $10.
Right.
So you can very easily get something off the ground for super cheap.
Now, when you're doing that, do you worry about, like, do you factor in scalability? Like, what's this going to cost me if this thing really takes off?
Yeah, so that's a good. There's lots of like serverless by design kind of gives you some built-in scale where you can say I just want to up my RAM and you don't have to really deal with it. I think it depends all on your backing, sort of like your database and things like that. So in my products that I've chosen, I've looked at scalability. It's like DynamoDB is like something you can easily scale up like with 2 clicks. So yeah, you got to build with scale in mind, but if you worry about what this would be like at enterprise scale, you're never going to get it out or cost effectively. Yeah.
Tackle it on the front, and when it starts to scale, worry about it as it happens.
Yeah.
Cool.
One of the easy things that draws me to serverless a lot of times is when the application feels really functional. When you just want input, output, you don't care about state. Those are the easy go-tos for serverless.
Right. So how do you deal with state? So like in an application lifecycle, you're going to need to manage state at some point in some database or some cache. How do you sort of integrate that within the serverless concept?
For me, with AWS, depending on what sort of state I need, like recently I built an application for taking all of our videos and all of our artists, so hundreds of thousands of videos and artists, and making sitemaps for all of that so that we can improve our SEO. And I realized that I needed some relational ability there. I needed to be able to do some joins and some queries. So I couldn't use something like Dynamo. I tried, but it was such a pain.
Yeah, I've heard bad things about Dynamo.
Well, Dynamo is awesome, but if you try to do a regular like SQL query,
right,
you can pull one item out really easily
right.
from a huge data set, but it's hard to like give me a list of sorted things.
Right.
You have to predefine all of your like what you're going to want to query on as the keys for everything.
Right. So I did end up just going with the SQL database from AWS. What do they call that? Aurora.
Yeah, on their RDS platform. Yeah. I've never personally used Aurora, but I've I've heard great things from that one as far as RDS goes.
One of the really cool things that Google just released was Postgres at scale, and so it's completely managed.
That's great. Yeah. Does RDS have Postgres within it as well?
Yeah.
I think so, yeah.
So that's fully managed.
And I think Aurora has like Postgres connections now.
Interesting.
And my understanding is Aurora like auto scales for you.
Okay.
So just so you guys know, I haven't done almost anything serverless, and I'm here sort of like to ask questions as an outsider that hasn't used it.
Sure.
So is it generally looked down upon to start using half state, like having a database that your Lambda functions using or whatever? Like, is that a bad thing, or is like she shouldn't be looking at serverless if you're having a lot of state, like having to query databases and do all kinds of stuff like that?
It's not necessarily a bad thing. You lose some of the trade-offs, I think. It's not as shiny when you have to keep a lot of state.
Sure.
Where you might want to just like spin up its own server for this one application. But scalability is another big plus when it comes to serverless, being able to, you can run the function once or a million times and you don't have to worry about any of that. And me, when I started it, I wasn't so into the DevOps side of it. I wasn't sure how to do a lot of the server management stuff. So being able to just write my JavaScript function and say, okay, now you take care of it.
Somebody takes this.
Yeah, it was awesome.
I mean, I guess you still have to scale whatever state you have behind it, right?
Right.
So I guess as soon as you have a database, then that kind of, like you said, then the database is your limit to your scalability.
So one of the key things that really enables the trade-offs that Mark was talking about is the nature of the horizontal scalability of the serverless. Serverless in itself isn't necessarily a definition. It is not a service. I've heard it referred to as kind of a framework. I would almost refer to it myself as more of a paradigm of and a way to run your code, basically an individual VM for every instance of code action. And that scalability of the horizontal sense works really well when your data store also scales horizontally. So like S3, if you're manipulating a lot of files, S3 can throw the files as fast as you can take them. And so a function-based serverless approach works really well. So if you were resizing images,
you just throw the function to resize, and then you can throw 1,000 of those up because S3 can handle you storing 3,000 images in a second.
Mm-hmm. With the way that the AWS infrastructure is all like interconnected, it makes it really cool because you can then set up with like Kinesis streams so that when something comes in, and it automatically goes through this whole pipeline of going through the serverless and then going into S3, and you can automate a lot of really cool stuff.
And from that perspective, because there are so many instances in just general application development that you can pull out those functional solutions. If you wanted to run all of your data validation, so say you had real-time data coming in from a very consistent stream, say it was a governmental source or something that was constantly pumping out data for you, those sources, you could run them straight through functional, and should that source happen to scale up for whatever reason, depending on the data set that you're working with, the serverless is right there waiting for you because it's going to scale with it.
Right. So it sort of just aids you in that divide and conquer, just out of the box, by merits of its design. So sort of dipping into by the design, we're familiar with these providers. You've got AWS, you've got Azure, you've got OpenWhisk through IBM, which I don't think anybody's ever actually touched, but it's out there, and they're trying. And you've got a variety of other ones. I think Auth0 has their own serverless offering for
Google?
Google definitely does. Google Functions, Google Cloud Functions, I think is what it's called. They all have it to some degree, but from your perspective, what would it take to stand up a serverless architecture for somebody else to utilize? No. I mean, so
is this directed at me?
It is.
Okay. So one of the things that I would say is know why you're jumping into the function. Right. Without a doubt. Know why you're jumping into it, and if your use case does support it, look at how your organization finds talent. Look at how it finds the skills in the market. Look at how you have historically reacted to change. All of those things kind of go into which provider is actually going to be the best. I've come into situations where somebody has gone, we're full AWS. Why?
Because everything else.
I don't know.
is
I'm like, are you using? Oh, we just spin up. So you are using EC2. You're not using any of the load balancers. You're just on AWS, and you're getting a bill from AWS. You're not into the full ecosystem. And so, but if you are already heavily invested in the AWS system, I would totally recommend that you stick with their serverless.
Yeah. So you're not like, I've got all of my load balancers through AWS. I'm using Redshift and doing all these other things. I'm going to use Google Cloud.
No.
Yeah.
No.
Stick
And
with
I thought your question was, how do you become a
Right.
provider?
Yeah, so if you were looking to become a provider, say
new
like,
one.
so the argument I've heard for this,
Pick one.
let's just roll with it. What I've heard is if you're standing up one, first off, it's when you're at an enterprise scale, and you don't want to go external of your own network, and you want to abstract the server away from the developer. So they have like a team of DevOps, and they throw up a Kubernetes cluster, and they're essentially these containers that are always warm. So we'll get into that a little later. And then they just have their developers writing against their own serverless infrastructure. How feasible is that? Is that nobody does that, right?
Well, that's a tricky question. My house has a load balancer,
Right.
so I don't know.
I like your house.
Feasibility. Yeah. So I'm actually doing virtually the same thing in my own home environment, just to essentially answer that same question of what is the feasibility, because I think with the opening of all of the open source projects in the space, being able to assemble that architecture is becoming easier and easier.
Right.
But at the moment, I don't think there is a full solution that you can just say, I want to turn that on.
There's not just a container and Docker Hub that you can pull in.
The serverless.
I mean, you can get a couple runtimes that would probably run a particular type, but if you want a full organizational, like there's a lot that goes into it.
And that gets very contrived. So on that topic, when you've been doing these serverless functions, have you run into any issues with the warm-up time? And has that dictated the language you pick? Like, is C# or Java on AWS going to take much longer than Node to spin up? And has that been a deciding
I
factor?
heard it takes longer, but
Right.
I haven't even tried.
Did you just go straight Node?
Yeah.
Yeah.
Same?
Yeah.
Seems to be the go-to.
In there, back when it was, it's gotten a lot better. It used to be like if you hadn't run it, it did take a while to spin up.
What's a while?
Like 30 seconds.
Okay.
Yeah.
Wow.
Like a series.
Yeah.
30 seconds of function. And that's
Yeah.
that's when it's not been used at all lately.
Correct. Yeah.
And that would be,
That's
just for clarification, that would be for new connections that are not being able to be picked up by existing
Right.
workers. And so if a worker finished its process, it would be able to pick up the next
Oh,
one.
yeah. Yeah.
Which happens.
So you're not completely dead in the water, but
Yeah.
it does slow you down.
It just takes a while, but
That happens both when you haven't had any traffic for a while and when you have more traffic than, like when you have a sudden burst of traffic.
I see, because it's
So you
got to
gotta
spin up
bring
new
up
work.
more than
Yeah, then it has new
warm.
workers.
Yeah.
It has to spin up.
But what I did is used itself is built like a health check into it, and then ran a cloud watch event every minute.
Yeah,
It
to
just
ping it and
says,
keep
"Are
it
you there?
warm."
Are you there?" Yeah.
Yeah.
So it's
And that would keep it warm?
that would keep it warm. It's like 1 cent a month to keep
I see.
doing.
Does that allow you to pre-scale? Like, so that if you're starting to burst and it's starting to go up, can you
Yeah.
get ahead of it and warm up nodes as you go?
You
So-
could potentially build that.
Yeah.
You
Yeah.
have to do. So that solves the like no workers are live
Yeah,
problem.
correct,
That does
yeah.
not solve the burst of traffic problem.
Yeah.
I found, and like you could in theory do that like at scale to like have multiple workers live all the time, but then at that point like you might as well be using EC2, just have a constant warm.
Yeah.
And I'm not familiar with the exact service or the terminology, but I believe that one of the things Google's actually offering in the space is they will actually keep, and this isn't necessarily for the serverless side, it's more related to Kubernetes and the cloud, but they will keep your containers warm for you. And they will sit there, and you won't get billed for them until they start serving traffic, and so they'll have them running.
But will it solve the scalability problem though?
So that with
The
the
bursting
Kubernetes,
problem,
the
sorry.
Kubernetes, it would, because they are spun up behind the load balancer, and so as the burst of traffic comes in, if the other servers begin to fail their health checks, now this new server is coming in and it's already warm. The warm period is related to how long does it take to get this VM spun up? How long does it take to get everything into memory? How long, like all of those factors go into that warm up period. And if you're on brand new SSDs, it's pretty quick. If you're not, variable.
Interesting. That's an interesting concept I hadn't really thought about. And plus now, most all of these I think are running in containers. So that's drastically reduced. I think that brought about the whole concept of serverless even being an option.
Yeah, I feel like 30 seconds, if I was to implement it on something, would block a lot of reasons why I would want to use it.
Right.
Like, let's say I want to spin off a job to send an email on a password reset or something like that. If it takes 30 seconds to even warm up and then send an email, that to me is too long. So there's certain. I feel like it cuts off your use cases a little bit, depending on where we're at with it now.
Keep in mind, this is like 2 years ago when like it was just.
And I've heard this problem is one of the biggest downsides, at least at the time.
Yeah.
I've never had longer than 10 seconds for
Okay. Yeah. And that seems fair.
Yeah.
And do note with your exact example, if your existing solution goes and says we're going to check every 5 minutes or every minute and do a batch email, you just knocked it down to 30 seconds. So if your manager's looking at you, you just got a 50% boost in speed by switching.
Right. I guess it all depends.
Yeah, but if I'm a user waiting for that email and I'm waiting 30 seconds, I'm like, where the hell is it?
And I've had that experience.
And I get pissed off when it happens.
Yeah, I say, forgot my password, I hit send, and I go to my inbox and I'm like,
where queue is processing my work? I know there's a queue out there.
We have the attention span of like a goldfish.
Well, it's just we've come to expect this immediate gratification. I think serverless is sort of, from an engineering perspective, you have to be aware of those warm-ups and you have to build your system around
Right,
them.
and I think it doesn't necessarily limit, but you just have to be, like you said, be aware, have solutions to warm stuff up so that depending on, because if 30 seconds doesn't matter, then you don't even need to do anything. You just use it and scale it and it's fine.
Nightly jobs, stuff like that, 30 seconds is a drop in the bucket.
Right.
But that goes on the other end of it, is these functions that run in Lambda or wherever, they have a certain amount of time that they can execute before Lambda cuts them off. And kicks them out. I forget. It's like 500 seconds. Yeah. Okay. So that's not long.
So there's a workaround, and it's a hack, and we have done that in production. Maybe I don't know if I was supposed to say that or not. It's not hackable.
Yeah.
But
it's just is.
No, you can check to see how much time you have left on your function, and so if it's below 20 seconds, you can spin up another one where you're at now.
Right.
You could also end up in infinite loops.
Right.
Which would be costly.
Yeah.
And that's that's a divide and conquer, but it's more of a streamed approach where you're like, okay, we're running out of time, so let's stop this work, package it up, send it off to the next guy. He can pick it up.
Make your work smaller.
So I have one of those in my backfill function. So I take all of the content from our main databases and take out just the information that I need for sitemaps and put it into my database. And so to run through all of those, it takes way longer than 30 seconds, or than 5 minutes even.
Right.
And so I end up having to have a pointer that I can then say, okay, start from here, and just keep going.
Yeah, interesting.
And so I guess my question around that is, for these cloud providers, what's the benefit of them doing that? Like, why not just have a function that can run as long as they want to pay for it? Is that
the main benefit, and this isn't unique to AWS, for example. Salesforce implements similar limits to you, and it's actually baked into the language level. But from that, you will have that nature of the time, the implementation. And I just completely spaced on what I was going to say. I'm sorry.
It's all right.
So why would they give you the time limit?
Yes, thank you. The limitations are there to protect the cloud, and by protecting the burstability on their end, by saying we can schedule at the millisecond level, we will be able to predict how much we're going to need. We'll be able to spin it up on our side for all of our clients, whereas if you don't enforce some of those limitations,
it's a lot harder to guess what load you're going to be looking at.
You actually wonder what the upper bound of availability of all the serverless is, right? Because at what point do they throttle what their allocation?
Yeah, they gotta.
or is it like at night or during the day? Because I'm sure like web traffic obviously spikes during the day, but are they spiking at night when everyone's throwing their
or is Asia throwing things out of the loop in that region?
Yeah.
So are there similar limits on all the other ones? I know familiar with Lambda being 5 minutes. So one I'm familiar with. Is it same with like Google Script, whatever, all the other ones that are there? I've actually never looked, so I don't know. I assume it is.
Okay. I think Google has similar limits. I'm not as familiar with the limits. I try to stay as agnostic to the platform. I actually try to stay out of the weeds with AWS of all the fun toys that they do, so that I can pick up and move.
Right.
So.
I just know that for some of the stuff I'm working on, we have workers that take longer than 5 minutes. Mm-hmm. So like if that's the case, and then either I have to come up with something where I can have a pointer, or maybe it doesn't apply in that case, and it's the use case.
Or
is
have to
something
rethink the problem from the start.
Sure, right.
Yeah, and in that case, I would suggest start with can you front load the data? Can you get a hold of all of the data that you need to run that process before you even kick the process off?
Right.
And maybe that's where most of
that 5 minutes is waiting on APIs to come back with data.
And so if you had other serverless functions that prepped it for you,
so you're chunking it.
And this goes right back to your question earlier about state, on how do you manage state. And so as you start pushing requests deeper and deeper into your stack in this regard, in a functional sense, you have to just take the state with you. Whether that's through an external source of like a database that is tracking the state for you, so when the function gets a hold of it, it knows what it's doing, or if when the function is called, it's handed all of its state, and it goes forward.
Now, can say a Lambda function invoke another Lambda function and just pass that state along with it?
Mm-hmm.
Seems like a reasonable way to do that.
That's interesting.
Sounds like how you did that hack.
Right, exactly. You can use SNS, which is like the messaging system within AWS, to then launch other Lambdas and pass along information. So I say, hey, next cursor is this one, and just keep going.
And there's no concept of which function is going to pick it up, because they're all the same function.
Right. Yeah. And you want to keep it that way. The idea is they're all the same. Anything can pick it up. Nothing special about it.
You can you can break up your processing into multiple functions. But if you're processing the same thing, then it's the same function.
Right. I see. Are you guys afraid of lock-in? Like, now you've built on Lambda, you've built his function as a service. Are you concerned about that in any way?
Terrified.
Yeah.
So does the serverless framework alleviate any of that for you? Is that like an abstraction point that is reasonable, or is that too restrictive?
So like serverless, the framework offers, they like, oh yeah, we run on everything, but a lot of their like
all the YAML is all very
like what's your IAM permissions and all that stuff. So yeah, but I think like again, I'm just coming from my side project that I brought off the ground. Like I'm willing to like start it and test it in a totally like AWS world. And if it grows and like needs a different sort of architecture, then you can you have this like JavaScript isn't or Node isn't AWS lockdown, so you could modify it to suit whatever you need down the road. But
is the actual code that you write, the function, is it specific to that technology or to Lambda, for example?
Yeah. So unfortunately, yes, it's like
is.
I'm using SNS to test things.
If you're using any of the interconnectivity between there, so SNS and there's S3 and all the
Dynamo is like.
But you can write your
the
function
Kinesis streams, everything together.
Yeah.
Sure, if you're using all the AWS functions, but you could write if all I'm doing is delivering an email to an API that's not AWS, and that's all the script is doing.
Just your node function. Right?
Then I could switch it to another
totally
provider.
You'll have like a wrapper around that takes I guess depending on how you do it, but like most Lambda has a very specific API of how the call comes in, and typically you would wrap that in something that's pretty Lambda specific, but you'd want to like minimize the functionality that touches Lambda.
Yeah.
So for your email example, you'd have like an API endpoint that got hit that sends the email and has this post data. That post data then gets set from the endpoint to the Lambda in like an event. So that is where your the difference might come in with a different architecture or infrastructure, so that the event might look completely different on a different infrastructure, but it wouldn't be that difficult to change.
Right. And I'm surprised, like, what's weird about serverless is they say when you start a new project, it's like use the AWS implementation of that event in context, and like if you're doing an API post, like it's going to be an event.body. Some weird stuff.
Right.
Yeah.
And it's fun. I'm thinking about that now. Is like if we're working towards a kind of a vendor neutral sort of setup, you'd think that the tools would have that kind of like wrapper functionality of like you're always passing your Lambda function as like a unified vendor neutral sort of event rather than AWS specific or Google Cloud specific.
And do keep in mind the vendors that are pushing this technology are the ones that want the vendor.
Oh,
license.
yeah.
So
Yeah.
Right.
there's no real motivation for
Yeah.
them.
Right.
Yeah.
Some open source consortium comes out and says these are the rules. This is what everybody should follow.
Yeah.
Now we've got one extra standard.
Yeah.
Right. And there's a great XCC, whatever.
Yeah.
It's my favorite. It's like, came up.
We need a standard to eliminate all the standards. Now we have another. Yeah, that's wonderful.
Yeah.
So, and I pulled that too. I just lost my complete train of thought. So we've addressed you're not really concerned about the longevity of your scripts running. You just sort of build around it. I kind of want to poke you and ask you about, because you wrote, before your cryptic application, you wrote one for the Washington, D.C. Metro.
Yes.
Which is sort of tongue-in-cheek. It's sort of fun.
Yeah.
You want to talk about what that was like building that? Was that your first serverless application?
Yeah. So I used to live in Washington, D.C. They have a subway system, metro system. It used to always catch on, and it still does, always catch on fire. Like the track would literally erupt into flames. Yeah,
Literal.
like actual fire.
Oh, cool.
And like, yeah, so I one day, happy hour after work, we were right outside a metro station. I saw a bunch of fire trucks pulling up, and I looked at ismetroonfire.com was available, so I'm like, buy it. And then that weekend.
Wait, what year was this? Was this in the like prime of is whatever?
So
domains?
so it's funny is that site eventually turned into the technical term is single serving website,
Yeah.
but so I built a service that allows you to register a domain that's like, are we in Denver? Like
We have one. Is there a fucking Rockies game?
Yeah,
.com.
yeah. But so if you go to boolean.com, that's built on Lambda. That's actually a full Express API that I ran through Lambda on Claudia, if you've ever heard of Claudia. But anyways, so so I bought this web page. I was manually checking Twitter and like pressing a button and like updating the HTML. It was like me doing it manually. I'm like, I'm sick of this. So that's when I first forayed into Lambda. So I did it with no like framework. Serverless wasn't a thing at the time. I just looked at Lambda and built it. So I ran it every 15 minutes. It would go out and check Twitter. If people were tweeting about a fire or smoke, I would then send a tweet. Yeah, which is hard in itself on Lambda because you have 50 megabytes of space to do whatever. So that that was a perfect use case for Lambda. Is I wanted to check something, an API for every 15 minutes, get it back, process it, and then do something if the indicator was true. So
So did you host static HTML on S3?
Mm-hmm.
Nice.
And actually, so the Lambda, this is like I am very cheap in the way that I did this, is I built a JSON API, but it was actually hosted in S3. I would just make a JSON blob and put it in S3 and then call it, that was my data store. Yeah. So like the thing costs like 50 cents a month. And we got like Uber advertised with us. We got featured in the Washington Post in 538. Like the ROI on that was like I spend 50 cents a month on it, and it makes quite a bit of residual. Yeah, so it's like we have a clothing line.
That's nice.
Yeah.
So this was as opposed to running a server like all day. That's
Correct.
Just running a cron job or something every 15
Yeah.
minutes. And
Yeah.
that would
With
be
nobody
way-
hitting it unless there's fire trucks outside Metro.
Yeah. Yeah.
Cool.
So that was my. So again, I started manually. There was maybe a 2-week period where I did have a Heroku thing that was checking it, and it was like $20 a month, and I'm like, that's way too expensive. So I was like, how can I lessen that? So yeah, that's how I kind of came into Lambda and learned to love and hate its intricacies.
Right.
Sure.
Yeah.
So is there like now an API to check for fires?
There is.
Is there really?
Yeah, it's actually what's weird about DC is like they have policy nerd people there all over. So like
Right.
the metro and data around that and open data around that is something that people like love doing in their spare time. So I partnered with a bunch of like app developers who want to use that for their apps and things, and I share data. They share data with me. So yeah, it's a odd. It's not like a business. It's not really like a business case of like our infrastructure is running on it. But again, to the cost and the ease of standing that website, if you call it a website up, was minimal.
Right. So you say you store it static HTML in S3. How do you serve that out?
Through CloudFront. So so it's a public S3 bucket, and only my Lambda function has the authority to update that bucket. Yeah.
So you just keep the policies within your VPC,
Yep.
update it, and then anybody can read from it in CloudFront. Distributes it.
I really like that.
Yeah.
You can do distribution directly from S3 too. You can just assign a domain name to your S3
Oh, right.
bucket.
Okay, yeah.
You don't get SSL though.
Well, you do if you put CloudFront in front.
Yeah,
In front of
yeah.
it, and then you get
Well,
your
S3 is
SSL.
kind of slow at serving assets too in comparison,
Right.
right?
Yeah.
It's not really designed to.
Yeah.
Yeah.
That's why you throw a CDN in front of it.
Yeah.
It's cheap.
It's
So
very
it's
true.
true.
And then the CDN
Yeah.
would be an extra layer of cost.
Right.
But then again, CDNs
Again,
are.
it's like 50. CloudFront is pretty cheap if
Yeah.
you tweak it right. Yeah.
Yeah. And you keep the region to US.
Yeah.
The
Yeah.
moment you go overseas, it's like, why? Okay.
Yeah.
All right. Well,
Wait,
we'll
Asia
be
doesn't
doing
want to
that.
know if the mattress on fire?
Well, it's funny because I look at Google Analytics and like Russia like it will spike like oddly. And I'm like,
What's
That's
going
it.
on?
All
That's
cloud traffic from Russia is like,
yeah.
we know what's going on.
Yeah.
Especially into DC, yeah.
Yeah. Yeah, exactly.
Yeah.
That couldn't be the Kremlin. Anyway, that's fun. So that starts as just like an idea at a bar,
Yep.
and now it's this whole thing. It's
Yeah.
pretty cool.
Yeah, and then so we turned it into me and my buddy. We turned it into like a service where you could register it yourself,
Right.
and that's also that whole service is also running on Lambda through Claudia. Yeah.
Beautiful.
Yeah.
Very cool.
Awesome.
So, what do you have standing in production right now that is like the pinnacle of what you've done in Lambda that you're semi-proud of?
The stuff that I've done is just that that sitemap generator, along with a couple of Alexa skills. I gave a talk at Developed Under
Oh, yeah.
Alexa.
You lit the channel on fire, right? The
Right,
Drupal channel?
right.
Good job on that, man. Great stuff.
We have some stuff running in production. A lot of our content services are on all serverless stuff, which is really cool for pulling out one video, one artist really quickly from Dynamo, processing data as it comes in from the labels, this raw data that then needs to be turned into information that we can use and then served up to all of our client applications. Where some of the trouble comes in is trying to do more of the relational stuff, but using Dynamo, so you end up with different I don't know, index tables or whatever. I don't remember what that was in there, but so I think they wrapped Elasticsearch around it, so that we can get the top 20 videos for today and stuff like that.
And that sort of leads into the architecture of serverless, because serverless itself it sounds very simple. You've got a function that runs, but it's so much more than that. You've got your Redshift, you've got whatever other services, cloud providers, and you have to choose the right ones to wire all up together in this weird vendor lock-in diagram that's just like, here's like what happens, what we have to fix when they inevitably deprecate something. You're like, I have no choice.
With that sitemap generation tool, I actually like the way that AWS all interconnects. So I'm listening on Kinesis streams for updates to the content services databases, and then I get events in there, and they can be queued up. However many events happen at the same time, and so that's when stuff gets updated, deleted, when new videos are added or new artists are added, and then I take that, run it through my services, and add it to my database, and then the one that actually generates the sitemaps happens on a timed basis, so it's like every 4 hours or something.
Right.
Cool thing about that is that with these huge databases, I can still say I can chunk it out and then divide and conquer and say, okay, I want to build sitemaps page 1 through 10 all at the same time, and then build the index and build those all for all the different territories we have too, which is really cool.
Yeah, it's sort of sounds great for manipulating data, structuring data. Not so good for, like you said, like relational things where you're like, as long as everything you're using is chunkable and scalable horizontally, then that system's going to work really well. Otherwise, maybe not do it. What are some downsides? What would be a functionless or a serverless killer that would make you decide not to use serverless?
My company, we serve about 1 billion requests a day.
Right.
So it's not very cost efficient for us because it's like $3.50 per million API requests.
Yeah, you can just rent a bunch of servers that run.
That's like
stuff.
$3,500 a day
Yeah.
of overhead for us. So that's just one aspect of the company, but obviously there might be some more back-end apps that could use it, or it's underutilized there.
Right.
But that's why there's one major reason we haven't implemented serverless.
It seems like a sort of double-edged sword. Like, yeah, it's super cost-effective until it scales. And then you're like, okay, well, we're handling all these requests. We might as well just have long-standing servers that aren't doing API gateway requests and charging us every time they do that. They're going through our load balancer and charging us much less than a gateway request. And we just have our built-in router in front of it. So is there a point where this topples over? You get too big and you're like, all right, we got to refactor everything out of serverless now. Or is that cost going to drive down as you scale?
We can add more CDNs. You could do some clever things to not actually hit the servers as frequently.
Well, there's no reason that your serverless functions need to be serving your API. They can be processing the data for your API.
Right.
They can, like serverless. It does work very well for hosting small APIs where the data can easily be accessed, or the cron job style. It works really well for that. But it really works as standalone units, and that are more or less going to have consistent load, but could scale at a moment's notice. Make very good use cases for it.
Sure.
One of the best things is that you pay for runtime, so your crappy coding is directly affecting how much you have to pay. If you can make a function that runs quicker, you pay less.
Yeah.
Right. And your developers now have an extreme incentive to be very efficient in the code. And a lot of that goes into the languages that these providers allow you to have, which is another interesting thing. So you've got Node available on AWS. What version of Node is that? 5 something?
6.10.
6.10. What's the latest? 8?
They don't have 8 yet, I don't
Yeah,
think.
they don't have 7. And what?
Well,
7
they
7 is
didn't have
unstable. 8 is the
6
latest.
until-
All right.
Very recently.
Yeah, they're pretty slow to.
Yeah.
It was 4 something, and then they just most recently went up to 6.
Right. Okay.
It's
So
optional.
they're
Right? You can
making-
choose which language you run.
No, you get one language
Well,
and one.
Choose.
You can choose, but they'll gradually deprecate the older ones.
Okay.
They just got rid of Node 0.1.
That's amazing.
So slowly.
Yeah.
I didn't realize they backwards supported that far.
Yeah. So when I was working at a large corporation who had like a lab cloud, and
Right.
they were very old school developers, and we got all their emails, and it was like, oh, Node 0.1 is going away.
You're like, panic.
Yeah. Yeah.
Rewrite.
Yeah.
So they just released support for Go, and in that they said Go 1.x. So the interesting part about that is they're not only supporting Go backwards, they're supporting Go moving towards the future. And Go is a compiled language, runs super quick. I imagine the warm-up times are akin to like Node or something that's very lightweight versus the Java, because you've got to have the JVM, right? So they've got a JVM sitting in the Lambda, which is wild to me on its own. So it seems like Go is very well oriented towards a serverless sort of environment. Would you let the language and the speed of that language and the offering of that dictate how you write the code, or would you pick what you know if it's supported?
So I actually dealt with something like this. I needed a Markov chain and I was trying to do it in Node. It was super slow. So I actually wrote one in Rust, and was able to build it on an EC2 instance with Amazon Linux, and then run it as include it in my serverless package as a binary, and just call it kind of like with a syscall. So I think you'd be not. It wouldn't be a wise idea to kind of like go with the experimental or try something new. I think I don't. Does anyone else use any other languages?
So one of the upsides for the Go would be everything is compiled into the binary.
Yeah.
And so that works really well. The serverless paradigm. Node, you can get very close to it if you do the Webpack and minify everything down into a complete shaken bundle.
Yeah. Yeah.
People were running Go on Lambda before they officially supported it.
Yeah, I saw the wrap around that, and I was like, nope.
Yeah.
You can run any binary on Lambda if you just have to wrap it in one of their supported languages.
Yeah.
Interesting. I don't think there's any other languages I'd like to see in serverless, to be honest. Like, Go's great, Node is great, Python's great, but like, I don't understand why Java's in there. I still am beside myself on that one. And then C#, I guess you have to support like that enterprise idea, like somebody's used to writing C#, they're a .NET shop and they want to use serverless, but it makes you wonder how they sort of picked that variety of languages. Do you know what languages they initially launched? I think Node was a native, like one of their first ones. So I think that's why it has had a huge amount of adoption.
Yeah.
So Scott, what do you got going on at Move On that uses serverless?
We're kind of all over the place. We do like very simple functions, just like data processing with serverless, but we also do full apps as like through API gateway. Like any, we do like a full Node app that like people hit API gateway, it calls Lambda returns like the HTTP response, and that goes through API gateway. And like we have like, we're working in politics, so like people get very excited about something for 10 minutes, and so we have like super bursty traffic. So for us, the cost is much lower with doing basically anything on serverless, because when people aren't paying attention to something, then the traffic is way lower, and then suddenly Trump says something and everyone's excited about something, and we have like 1 million requests.
I'd love to see those analytics.
Right, yeah.
Ties his Twitter account to the analytics
Of Move On.
of Move On, for example. Yeah, that'd be interesting.
I'm sure
Yeah,
there's
sorry.
With a serverless function.
With the serverless one, of course.
It's almost like your villager analytics. You're like, this month, a lot went down.
But yeah, we take things that we would normally run on EC2 and just move them to Lambda, and we find our costs go down because like when we're not getting traffic, we're not paying anything.
Right. Which is very nice. So on that thread, like you said, you do very process-oriented, probably almost considered functional in the way that it progresses through the scripts. Has anybody even tried to introduce the idea of object-oriented into a Lambda function that's running up there? Or is it just like, get in, do your work, get out?
Maybe for parsing, I can't imagine why you would need to.
Right.
Maybe like a sort of like a mini ETL type of thing.
I mean, it seems well positioned for ETL.
Yeah.
Because it's just mutate that data and move on.
Still seems very functional.
Yeah.
Yeah.
On a unrelated note to everything except the ETL, working through a very massive ETL recently taught me the one thing that Mongo is good for.
What's that?
ETLs.
ETL.
Because they're just much better than trying to keep it all in Node's memory, because you will just crash the process.
Yeah, I could definitely. And like you said, you've got 50 megabytes in Lambda, and who knows what else in the other providers. So working on any large amount of data makes sense. And you wouldn't want an RDS or anything, any relational database at all, to sort of back that up. So it makes sense in that way. They should change that slogan on the Mongo website. Good for ETL.
I could see maybe object comparison might be useful.
In what terms?
You're talking about object oriented.
For object oriented.
Yeah.
Object comparison, just like building them out and then doing like a equality check between the objects.
Yeah, maybe.
Yeah.
Something like that.
I mean, I feel like I can write more elegant code when I have objects, and I can do a more object-oriented style with testability. But I guess your functional stuff should be very straightforward. It seems like it shouldn't do a whole lot where you need that kind of.
So I've adopted the functional purists do not like this. I've talked to them at length about this, but I kind of adopt a dirty paradigm with my functional. In the regards of I take everything that is strong with object-oriented and all of the type safety that you get by following that paradigm, and treat those objects functionally, never mutating the object, never trying to return that changed object.
You're always giving
always a
immutable
forward
instance of it.
motion.
The immutable concept.
Very, very, very immutable, which then turns around and your code lends itself very well to the serverless.
Right.
Gotcha.
And
Makes sense.
I'm a big fan of immutability out of the gate. We do a lot of stuff that ends up in a relational database, and then naturally it's backed by an RM, so that kind of goes out of the window. But it makes sense to kind of keep that concept within serverless. So, cool.
One thing I'd like to know, though, based on all the experiences from serverless, is how do you deal with reporting for do you ever run like a stats D, for instance, through any of these to monitor like the time it takes for the processing to run in mass?
Talk about like the analytics of the of these functions.
Mm-hmm. So I push from my functions to a stats D, but that's one of, and I push the processing time. But whenever like a problem arises or I need to debug, that's where I think serverless or the paradigm of serverless stinks right now. It's like it's very hard to like get in and figure out what's going on.
Right.
It's like a bunch of console. It's a bunch of
console logs.
You get like CloudWatch tells you like the exact millisecond when an invocation started and ended.
Yeah.
But it's like I spent a couple weeks like fighting with the CloudWatch UI before I eventually decided like I should just pull down all of this and look at it locally, because their UI is kind of clunky. But it gives you like pretty detailed logs on what's going on.
But it doesn't tell you what inside your function took a while. It's
No.
just like it took this long.
Yeah,
No,
so
you have to.
You don't get a stack trace or something like that.
Well,
that
and
shows.
so
Yeah.
They do have that X-ray that they're pushing. I see X-ray a bunch where it is like a stack trace of
your function.
Yeah.
Well, I think it's so that there was a Google paper, Dapper was the title of the paper, and a lot of these tracing paradigms are sort of coming out of that concept,
Yeah.
where it's just these spans are held within this tracing framework or whatever
Yeah.
you want to call it, and sort of that at the end of the day or at the end of the function gets shipped out,
Yeah.
and then you can see throughout your function what took what amount of time.
Yeah.
Don't ask me how to do that in serverless. Couldn't tell you. But it seems like it would lend itself potentially well there. Or maybe AWS will release something that does that automatically. I don't know.
I mean, honestly, for the short term, I would kind of hack around it, and I would do as best as you can to call that function locally in a loop and debug it locally.
You got to find out what data went in there to cause the problem.
That's very true. It's very true.
So it's like exploratory surgery. You're like, I think I found
So how
it.
do you develop? Are you developing against Lambda, or do you have Lambda running locally to run your functions through? Like, as a developer, how do you work through that?
I don't actually use Lambda, so that would.
Or any
I don't know if there's a better way to do it, but what I do is I have I call the event emitter or the part of my code that's going to accept the event with a structured event, and then I mess around with that, hit some edge cases and stuff. But I'm sure there's a much cleaner way to do that. But locally, that's just how I just play around with it. And,
I do all my. This goes back to like the vendor lock-in thing. Like anything I write that's like a single function that's just running in Lambda, I write the function with just like a standard parameter input. Then I do command line input so that I can run it locally, and then I do like a command line wrapper around the function that calls the function, and then I do the Lambda wrapper as well that like takes the same sort of input as an event in Lambda. That way I can both like test that it works outside the context of Lambda and test that it works at all, I guess.
That helps with portability too. If you're
Yeah,
looking to shift
and then
away.
then if I need to move it to another stack, I can just add another wrapper around the core
move that
functionality.
layer.
That's a good idea. I like that.
There's a lot of packages that you can simulate a Lambda environment too.
Yeah. Okay.
So I'm curious. Talk about Cryptic for just a couple minutes. Like,
Yeah.
How is that to build?
It was actually pretty interesting. So
He
it's
backed off of the fun.
it's super fun.
That gotta admit it.
Yeah. So it's built in the serverless framework, and what it does is it receives an API of cryptocurrency prices. If it moves a certain amount, a user configurable amount, it'll send you a text. So it's like perfect for serverless. Is you say, I want to know when Bitcoin jumps 100 or dips 100, and I have it checks the API of the price every minute. It'll run through a DynamoDB table of who's where and what they want to be notified, and then sends out SMS messages from Twilio. So
is that a function per SMS message that gets put out?
correct. So there's it's chained a little bit. So there's a checker function that runs every minute that will send an SNS message to all the different currencies, which will then say, let me look at my user table and see who needs a message, and then that function will invoke another SNS queue of the actual sending of the message. There's three functions that are kind of chained together all via SNS. Yeah. So you could do it all in one and just like do hope it finishes in 5 minutes, but that was more of an exercise for me to try and like really separate your concerns and say like, there is a function that all it does it sends a SMS message, so you can call that from a bunch of different contexts.
Did you get a lot of traffic in the last day or two? When
Well, so here's the problem: is the cryptocurrency crowd is technologically advanced, and this is
Sure.
I found the sweet spot of the market is old people who like don't have smartphones and like they just want to know when it gets. So like I've built it like for me like into the technology and like, but that sort of sector of the crowd loves APIs, and they probably have all these push notifications and stuff. So it's more for like the uninformed cryptocurrency investors.
So how do you send things to people who don't have smartphones?
Oh, it's all SMS.
Oh, they still have SMS.
Yeah, so I use and again, vendor lock-in is horrid with this. So I use Lex for their natural language processing to say like, if you said I want Bitcoin or BTC or every dollar or every one, so it kind of like helps me with that. But yeah, then I'm just locked into AWS.
Yeah.
No way around it.
Exactly. You're like, shackle me and let's build this
Yeah,
thing.
yeah,
I'm gonna try to deny it.
yeah,
And it's funny because you're on the serverless and you're like, well, that didn't really do much for me.
Yeah. yeah. So the higher costs are Twilio, because SMSs are much more.
Yeah.
Any thoughts to expand it in the future now that you see where the market and the demographics are?
So
So
if I were to do it again, I would build that API part in serverless and then do different channels of pushing that. So like I only built it around SMS and kind of that's dumb. If you're, I use it because my girlfriend got mad at me because I kept like just on an app so now it's kind of like a dumb
it's your
push
incognito
notification.
mode.
Yeah. But I think the core kind of like it's processing an API, figuring out who needs notifications, and then sending those out. That way I would keep in serverless, and that's a nice framework, and I kind of want to like open source it almost. It's so.
Sounds like it could have a good segue into an Alexa app as well.
Oh yeah. Can you push it? I don't think you can push things to Alexa, can you?
Not really.
Yeah.
No, but you can do price checking. So
Yeah. Yeah. What's
Alexa,
my
what's
price?
the price?
Yeah. Yeah.
Interesting.
Or what's the percentage change since I last asked you?
Yeah. That's a good one.
Context.
Yeah.
All right. Has anybody ever dealt with authentication inside of a serverless environment not like I've got a .env file that I push up and it, ta-da, everything has got all my API keys, but like real authentication, like a user requests something like Auth0 does, where it's like, okay, it goes out to the serverless, authenticates, and now you're granted access via whatever mechanism they choose. Have you anybody worried about that, or is that sort of outside the realm of what most people will ever need to worry about in serverless?
I haven't done what Auth0 does, but I have an app running that uses Auth0 for authentication.
Right. So you're just like, I'm gonna go to them, let them do the lifting.
But
What's
I
the
mean,
price
that
look
like
on that?
when the what did you say?
The price, is it worth it?
I don't know.
Just to not worry about it?
I'm not paying the bills.
Just get moved on.
But we don't have we're using Auth0 for a relatively small number of users, not for
Right.
like the masses.
Yep.
But like I mean, when by the time the request comes into Lambda, it's just a cookie that tells us who is authenticated. So it doesn't make much difference on our end.
Right.
I've never done the authentication. Well, I guess I have. I've done the we have Django apps running, which is just like a Python CMS. We have Django apps running in Lambda. But it's like, I mean, the request to log in is a single request that sends back a cookie, and then the next request comes back with the cookie. So it's not like, I don't know, it's not a like chain of functions.
Right.
Like a
And you're not doing
function.
anything crazy like OAuth, you're just going cookie-based and session-based on your data store. Cool.
What are the latencies like? Is Lambda regional in the AWS?
I'm sure it is. Everything is on
Just-
AWS.
So I threw New Relic on my API, and it was sporadic. Like it was like
Yeah.
So it's you, if you need like a consistent low latency all the time, like I don't think serverless is the right choice.
At least not right now.
Yeah, because you have cold starts, and then you have like I was shocked, like having done like servers that are like serving APIs and like seeing a consistent apdex. I was like, what is happening? So yeah.
And just out of curiosity, that wasn't because of the sporadic nature of the requests themselves, and that is when you began timing the app through your tool?
You're talking at time from request to startup of the script?
Correct. So like New Relic like rides on your process and watches what takes time and what function calls and what syscalls are taking all the time. So it was riding from beginning to end on that request.
Okay. Yeah, I was confused there for a second because I wasn't entirely sure if your graphs were showing high latency because they would go, several seconds between latency.
Oh yeah.
You don't pay for boot up time, right? Or if it's cold?
You pay for script execution.
Yeah, I don't think so.
Right, so if you got 10 seconds of boot up or whatever you want to call it.
I mean, you pay in like user experience though.
Yeah.
Of course. Yeah,
Ooh,
totally. No, as far as latency going up and down, obviously the boot or whatever you want to call it is up and down.
Yeah.
The actual execution of the script, like start to end, is steady.
No,
That's
it's sporadic.
also sporadic.
Yeah.
Okay, that's what I misunderstood.
Okay.
Yeah, so if I did not go as far as run a benchmark of like count and do floating point for 10,000 iterations and then call it a day, but yeah, the same function that was doing the exact same thing with the exact same context like might take 200, might take 400, might take 300.
And I imagine you're just being on different hardware and data center, whatever you get put on, and whatever neighbor is near you doing some work at the exact same.
Correct.
I can see that.
Yeah.
I wouldn't be terribly surprised if the way serverless is implemented in AWS is actually inside of the spare capacity of all the boxes.
The EC2.
Yeah. Yeah.
Seems like a good way for them to utilize that.
Yeah, and it's genius because like, of course you're locking. Well, like right now you're locking into them, so like they can probably take that as a loss leader and just say, yeah, we're just come on in. So,
cool.
Yeah.
Very cool. All right, so we're coming up on the hour, so I think we'll call it here. It was a good discussion. It's interesting to me how sort of limited the scope of serverless is, but how much you can do with it. So you've got your known constraints, and you need to know those constraints as you build the product, and then you say, yep, I can build a product on top of this platform, and go to it, and you end up going from like $20, just somebody sitting in a bar one night, to like, what'd you say, like
50 cents a month.
Yeah.
Which if you scale that to like $1 million server bill,
right,
that starts making a difference.
Yeah.
We didn't talk about Alexa much, but they built Alexa on top of serverless.
Yeah. Oh, interesting.
Because all of the skills are serverless functions, where then you, with that voice initiation, you're then calling up a function and having it give you back your output.
Okay.
Good to know.
Yeah.
It's interesting.
I'm sure, with the home assistants, and that's the thing, these huge companies are going to be all about paying for as little as possible and distributing the load as much as possible. So, all right, very cool. Thanks, guys.
Cool.